number 14. The answer shows the following equations represent the same plane. Well, if they represent the same plane, that means they actually can define the same plane. That means all four of the vectors have to lie in the same plane. So this one has to lie that way, and maybe that's the first one. And the second one can lie this way and this way. But together they actually define the same plane. The big key idea here is that they're coplanar. That's kind of the hint that they're giving us. It says express each vector in the first equation as a linear combination of the second equation. Well, if they're coplanar, that means I should be able to write this vector, so negative 3, 2, and 4, as a combination of negative 1, 5, negative 3, and negative 1, negative 5, and 7. And I should also be able to write this vector, 4, 7, 1, as a combination of these two also. And the whole idea of the equation of a plane is if you have two directions and a point, or just two directions, that you can write the equation of that plane. Well, if all four vectors are the same, along the same plane, they have to represent the same plane. So we've done this before, actually. This coplanar idea is one of our first ones. We can do this by setting up equations. So we're going to sort of set up parametric equations, kind of. So 2 equals 5a minus 5b, and 4 equals negative 3a plus 7b. And we're going to pick 2 to solve, and then use the third one as our check to check for coplanar. So I'm going to take this equation and times it all by 5. I'll end up with negative 15, negative 5a, negative 5b, and then I'm going to do my elimination. So looking at the a's, or the opposite signs, we'll add. We'll get negative 13 equals no a's. And if I add those two things, I get negative 10 b's. So in other words, b is 13 over 10. I'll go back to my original equation. Again, the original equation was negative 3 equals negative a minus b. I can now solve this for b. So rearranging, we'll get negative, I lost the sign there. Negative 3 plus 13 over 10 equals negative a. Or in other words, a equals 3 minus 13 over 10, which is the same thing as 17 over 10. Okay, we take our third one, that was this one up here. We'll do our check. Our check says 4 equals negative 3 times a, if it was 17 over 10, plus 7 times b, that was 13 over 10. And what do we do for a check here? We'll get negative 51 over 10, and 7 times 13 is 91 over 10. So we end up with 40 over 10, which is just the number 4. So we've proven that u up here is a combination of s and t. So definitely that vector lies in the same plane as the second equation. Now we've got the exact same thing, but we got to use the other equation now. So we're going to use the negative 4, 7, 1 and do the exact same proof. So how's it going to start? Negative 4, 7, 1 is made up of, it's coplanar with, we're proving, negative 1, 5, negative 3. And it's coplanar with the other one, which is negative 1, negative 5, and 7. And do our exact same proof. So negative 4 equals negative a minus b. 7 equals 5a minus 5b. And 1 equals negative 3a plus 7b. Again, we'll take this equation, we'll times it by 5. Negative 20 this time. Negative 5a, negative 5b. We'll add again like last time. End up with negative 13 equals negative 10b. So b is 13 over 10. Go back to the beginning. Negative a minus b. And I'm going to switch this straight off the bat, so let's just make it easier. So a plus b equals 4. What do you need for A? A plus 13 over 10 is 4, which means A is 4 minus 13 tenths. In other words, A is 27 over 10. So we've got an A value, we've got a B value. Let's do our check. Check. 1 equals negative 3 times 27 over 10 plus 7 times B. B is 13 over 10. Let's see if our math works itself out. 1 equals 3 times 27 makes 81 over 10. 7 times 13 makes 91 over 10, which makes a positive 10 over 10, which is 1. Hey, we've proven it. So because all 4 vectors are coplanar, they must lie in the same plane. And the only way 2 vectors lie in the same plane is if it defines that plane. So indeed, these 2 vectors are in the same plane.